polygons, we know that when we talk about polygons, we know that it is any shape with least number of 3 lines.
Okay.
Poly means many,
3 lines.
and less than 3 lines, we cannot make a closed shape. So for example, we have 3 lined, which is definitely named as triangle. And then we have 4 lined, which is generally named as quadrilateral. Quadrilateral is a 4-sided figure. And then we do have specialized names for them, which could be square, having all 4 sides and 4 angles equal of 90 degree. We may have a shape which is a tilted square, having all the 4 sides of equal length, having all 2 pair of parallel sides named as rhombus. Getting the point?
Yes.
And then a parallelogram. And we do have more 4-sided shapes. I'll stick to the concept of polygons for now. For example, another 4-sided shape is a kite. Another 4-sided shape is a trapezium, and so on. So coming back to the main concept of polygons, once we have 3-sided, and then we have a 4-sided, then we have a 5-sided shape. One more for this discussion, that is a 6-sided shape. By the time we talk about the shapes, we'll one by one write the formulas which could be used. So when we talk about polygons, they consist of number of sides and angles. Number of sides could be clearly seen and counted, but the magnitude of angle has to be found depending upon the given data. For example, if we are talking about this triangle, which we can see is a scalene triangle having all 3 sides of different length. But if I may be able to draw a triangle that has exactly equal sides, that is an equilateral triangle, and we would know that each angle is 60 degrees, right? And how do we know that? Because we knew
Add up to 180.
that's added to 180. That's supplementary. So they're added to 180, and 180 by 3 is 60 each. And for every successive shape, let's say we are talking about square, all these 4 angles added together, they make up 360. All these 5 angles in the next shape, they make up 540. So it's not about rote learning. So how do we know that? So we have formulas for that, which starts with sum of interior angles is equals to n minus 2 times 180, where this n means number of sides. So n minus 2 into 180, when we start with 3-sided, this is 3 minus 2 times 180. And the difficulty level of the question would dictate that if we have our calculator with us or we are doing it without calculator. In IGCSE, you have calculator in both exams. So this is 1 times 180. We follow the Damas rule and get 180 degrees. For 4-sided, n minus 2 times 180, number of side is 4. Remaining formula stays the same. That is 2 into 180, which is 360. 2 more to go. 5-sided would be 5 minus 2 times 180. That is 3 into 180, which makes it 540. 18 into 3 is 54. And then there's this 0. Last one for discussion. That is 6 minus 2, 6-sided polygon. That would be 4 into 180. And it makes it 720. So angle sum of interior angles is given by n minus 2 times 180. Following such, we now know that this sum would be 720. So when we know that, what we can do if we are given that it is a regular polygon.
All
Now that's a technical word. Sorry?
all sides are the same, or
That's right.
all?
That's right. With an addition that all angles are also same. Because if we say that we have a rhombus, so what happens? We have all four sides equal, but the angles are not equal in case of rhombus. Opposite angles are same, and these two opposite angles are same. So for regular polygon, there are 2 points in the definition. One is all sides are of equal length. Second is all angles are equal. So this word must be stated in the question if we are using these formulas. So sum of interior angles could be used for any polygon. When we talk about one interior angle. So we already had the sum of regular. Now this word right here gives us the permission to write this n below this formula. In numerator, we've written n minus 2 times 180, which we know that is the sum of all the angles. And if we divide it by number of angles, we would get one of them. So if it was 180, this is 180 by 3. If this was 360 for four-sided, this is 90 each. 90 each in case of square. If this was 540, 540 by 5 gives us 72 each. 108 each. 540 by 5 is 108 each angle. Moving on, that is 720. And these are 6 in number. So this is 120 each. Any confusion till now?
No.
That's very good. So we talked about one, sum of angles. Second, one of the angle. Moving on to the third part, which is sum. That's right.
Exterior angles.
Sum of exterior angles. Now, sum of exterior angles for any is always 360. These are our keywords, any, regular, and any again. So we can apply them even if they have different lengths. So that is always 360. What would that mean? That would mean this one angle, this second angle, this third angle. When we add these three, it becomes 360. In case of four-sided 1, 2, 3, 4, when we add all these four, it becomes 360. And so on. 1, 2, 3, 4, 5. All these 5, they add up to 360. And for the last one also, they add up to 360. Now, someone may ask that number of angles are increasing. We have 3 angles here. We have 4 angles here. We have 5 angles here. A student says that number of angles are increasing. Why do we have the same sum? That is because
interior angles are also increasing as well. So that means that it'll still be the same.
It'd still be the same because the magnitude is actually decreasing. So we had 60 as interior. This is 120. And when we had 90 as interior, exterior decreased. When we had 108 as interior, exterior decreased further. This is 120 and this is 60. So 120 times 3 was 360. 90 times 4 was 360. 72 times 5, 360. 60 times 6 is 360. And it keeps on going. We're just taking 4 examples for discussion and it keeps on going. The pattern stays the same, which gives us permission to write our fourth formula, that is 1. exterior angle would be for
180.
regular?
180.
Say that. Better that would be 360 by n. I'm taking it back. You see, these were our exterior angles. This is 120. This is 90. This is 72. This is 60. The angle outside the closed shape is known as exterior angle. 120, 120 again, 120 the third time. So they are different. And some would be 360. And in case of regular polygon, we can write 360 by n. That is 360 is the sum divided by number of sides. Last formula to close all these is interior plus exterior. That would be 180 because it always makes a straight line. Clear?
Yes.
So the question may be, okay, let me just minimize it so we can have a look at all the formulas. If the question is, find the number of sides of regular polygon. So it says find the number of sides of regular polygon, and what information is given? Information is that interior angle is equals to 140 degrees. Can you do that?
Mm-hmm.
Okay, give it a try.
The number of sides it has. 140. Um, 9?
That would be, that's correct. That's 9. Do you care to share how you did that?
I first subtracted 140 by 180, and then
That's right. I exactly wanted that you to do. There are many students who would choose this formula. There's nothing wrong with this. There's nothing wrong. But what happens? They would take half more minute than the method you chose. That's very correct. And I'll just quickly make comparison of both of these. So basically, I'm assuming that you went through this. You had the interior angle. You took out the exterior first, which is 40. And you knew number of sides would be 360 over exterior angle, reciprocate of this, making n the subject. And 360 by exterior, you got 9 sides. On the other hand, one interior angle was n minus 2 times 180, which gave this sum over n is one exterior angle. So 140 was already given. This is number of sides, which is unknown. 180n minus 360 by n. Cross multiply. 140n is equals to 180n minus 360. When we rearrange, this 360 goes on the other side. 140 comes on this side. And we are left with 360 is equals to 40n. 360 by 40 is equals to n. We get these two same things. That's right. Okay. So let's try a fun question. One and then the second one. I'm expecting that you can solve this first question, whatever I'll be writing here. is within 8 to 12 seconds.
Okay.
Expecting this. Okay. So this is the shape. Name is not given. And we are given with A, B, C, D, and this last angle is 40 degrees. And the question is find A plus B plus C plus D.
Okay.
Meanwhile, I'll just prepare the second question.
Okay. Oh, yeah. Okay. Okay.
Clicked it.
Yeah.
So what is it?
500.
That's right.
Oh, okay. Yeah.
It was five-sided shape. The sum is 540 and you take away 40 and you're left with 500.
Yeah.
So a similar question with even less given data. Okay.
Mhm.
Just- So this is the shape. And what do we call marked angles? What are those? For
Oh,
example,
that.
this sign right here, this sign in blue, we
Mhm.
call it marked. So I'm marking it with red. Can you think with the voice?
Hmm? No.
Think loudly. What are you going through?
Oh, okay. So is this like a regular polygon? No,
No,
it's not.
we can clearly see that we have different lengths And if you need this, we can write it as well, not to scale.
Okay.
So here's the tip. Whenever we have least information, we just try to understand the wordings and the shape, and we know that the information is missing. So we are not in a position to use formulas.
Okay.
We just have to, all these type of questions are known as educative questions. If you've studied them somewhere, you may be able to answer them.
I know that like not the top part, but like the sides and the
Yeah, the
bottom
side.
are the same. I know that like when they're opposite from each other, they're the same
They
angles.
are known as vertically opposite angles.
The opposite angles, right? I know that they're the same. So I just have to 540.
Like these in green are same, or we name them something, and these in red are same. They're known as vertically opposite angles.
Also in the shape when they're like opposite from each other.
Yeah,
Okay.
either they are top to bottom or left to right, they are equal. But we may have different values in two different sets. For example, if I label this one as G and I label the other one as H, so we may not be able to say that H, G, X, and Y are all four are equal. But yes, X is equal to X. These are vertically opposite angles, and H is equal to H. This may not be equal to G, X, or Y. Let me give you a hint. Should
Okay.
I?
Yeah.
For example, we have this question, and I ask you to find the sum of these marked angles. What would it be?
So it's also not to scale, right?
Not to scale. And we just studied it today.
We did. Okay. Um,
You want me to scroll back?
I have the notes on my page, but completely all of it 180. So all interior angles 180. And then,
You're getting closer.
sorry?
You're getting closer. Are these interior or exterior angles?
These are exterior.
These are exterior. You said something about 180 here,
Mm-hmm.
but what is the examiner interested in? He is interested in the sum of marked angles, which are actually exterior. What would be the sum of these three angles?
360.
360. That's right.
Oh, is it just all the sum of them? Oh, yeah, yeah.
And
Okay.
when we come back to the original question, if you notice, whatever the value is, they are actually marked 2 times. Should have 5 exterior angles. This was 5-sided shape. It should have been 5 exterior angles, but they are marked twice. So 360 times 2, sum is 720. Did you get it?
Hold on.
I'll make it clear. For example, we had this question
Mm-hmm.
and I asked to find the sum of the marked angles. This is 4-sided shape. So 4 angles should have been marked, but I'm marking 8 of these. So sum of 4 would have been 360, but 8 makes it.
Yeah. Okay.
Okay, one more. Or we say what could not be the possible value of angle Z.
Okay.
What I'm going to do is I'm going to draw a 4-sided shape, or not draw it, but tell you that this is WXYZ 4-sided shape, which is a quadrilateral, and we have few options: A, B, C, D, and we have more than one answer: 180, 70, 360, 400, and one more option which says 720. So what could not be the possible value of Z? Where is Z? It is inside a quadrilateral. Quadrilateral.
It can't be C, D, or E because it can't be over 360.
That's right. Now we have to choose between these two.
70. Because or else it would have to. No, wait. Sorry. Not be the possible. So A as well? Can't
That is right. That is right. It cannot be A because if that is 180, when we consider this 4-sided shape, suppose W, X, Y, and Z, if it is 180 at Z, it would somehow look like this. And it is no longer a quadrilateral. It is no longer a 4-sided shape. This now becomes a 3-sided shape because 180 is a straight line. Okay. Let me print that out. I have a worksheet for polygons. And we have few interesting questions. Yeah, I'll quickly solve the first one to just have a pace and warm up. The interior angle of regular polygon is 160. How many sides does it have? You've already been through one of this question. Interior is 160, so exterior should be 20, and number of sides is 360 by
Answer should
exterior.
be 18.
Sorry?
Answer should be 18.
Answer is 18.
Okay.
B part of the same question is A, B, C, D, E is a part of regular polygon which has interior angle of 160. So that's the same question. It was 160 interior, still 160. And it says to find the value of X and Y. Now this question is a merger of polygons and angles. Additional information is that CDLM is a square.
18 sides. Mm, 60 for one triangle.
60 for what?
160 for one interior angle.
That's right.
X should be 70 degrees.
X is 70. So this was 90. This complete was 160. And 160 minus 90 is 70. That's correct. What about Y?
What type of triangle is the other one? Is it like a, what was the name of it? Like two sides are the same and then one side is different. Two angles are the same and one angle is different. What type of
That is
triangle?
called isosceles triangle.
Okay. Is
You have
that triangle an isosceles?
Yes, that is it. And how would you be sure of that? Because these are sides of regular polygon, so all these four are equal. And then it is given that CDLM is a square. So if CDLM is a square, these four must also be equal.
Okay.
So having them marked B, C, and CM are equal.
Okay.
Is it comfortable to read or you want me to zoom in?
No, it's good. Uh, is Y 105?
Correct.
Okay.
So that's 70. Take out 70, you will left with 110. So it's 55, 55 each. And 160 minus 55 is 105. Very good. So here we are actually expecting that the student has the level that we can practice questions for grade 9.
Okay.
Let's try question number 10. Where I'm skipping these. We can save our time.
Okay.
Move on to these type of questions. Three of the angles of quadrilateral are 95 each. What would be the fourth angle?
75?
Correct. Interior angles of regular polygon is 165. How many sides? Okay, skip that again. That has the same nature. Okay. Yeah, this is little fun. A regular polygon has interior angle is equals to 160. And this is the question.
Sorry, you froze for a second.
A, B, B, C, C, D of 160. Interior is equals to 160 degrees. And using the data, we need to solve this. Calculate B, C, A.
Okay.
You did the same question in seconds.
One 145.
We're solving for B, C, A.
A. Yeah.
If I can just extract out the shape, interior angle is already given, that is 160. A, B is equal to B, C. This is BC.
Mm-hmm. Oh, okay.
That's an acute angle.
Okay. 10.
10. And that was isosceles.
Mm-hmm.
Next is B, B, C. We're solving here so we can see the diagram. D, P, C.
Mm, 30?
Let me check it quickly. It's
Wait,
not.
no, no, no. Yeah. 10?
Not 10. May I try?
Mm-hmm. Isn't it that like the two opposite angles like are the same? So it's like
Yes.
so 160 and then 10 to complete the triangle. We'd have to have another 10 and
Just have a look at ABC, the triangle ABC.
yeah.
And then if we have a look at BCD, both are 100% same. They
Mm-hmm.
are concave triangles. How are they? Because AB is side of polygon BC, same polygon, CD, same polygon. And if we talk about this left side, if this was 160, this is still 160.
Mm-hmm.
We already knew that these corners are 10 each. So this should be 10 without solving. On the other end, if BCD is 160, and when we take away this 10, it
150.
should be 150. And now we have these three angles. So P plus 150 plus 10 equals 180. That's 20 degrees. If this question right here, so far, if I would rate, you've been doing better than 90 to 95% of the students.
Oh,
This has a little higher difficulty, a little higher than those, but it is still part of O levels IGCSE.
okay.
We'll come back to that after this question. Question 14, then we'll come back to that.
Okay.
A regular polygon has 22 sides. Calculate the sum of all interior angles. So straightforward question.
Mm-hmm.
Do you remember the formula?
All interior angles n minus 2 160 over yeah. So 20 times 180 uh 3,600. Oh,
Correct.
yeah.
B part, two of the angles of the polygon are each 170. The
Mm-hmm.
remaining 20 are equal to each other.
Oh,
So we have to calculate the size of one of those 20 angles.
okay.
Are you doing these questions mentally or using
Oh, I'm
calculator?
using the paper.
Okay. Do you have soft copies of the books you're using?
Uh, yeah, I do.
So somehow, whenever you can, just share them with me.
Okay.
So we can like have a fair idea and gauge what resource should we be using.
Okay. 163.
Let me quickly check that.
Okay.
This is 600 when you took 172 times out. And remaining 20. That's correct. 163. Okay, coming back to this question. Do ask me if there is any confusion in the wording.
Okay. Okay. What I understand is that like there's this number of sides on an angle, but the interior angle is either 155 or 140, but there's like double the amount of 155 than 140 in the amount there is. So we just have to find the number of sides in that polygon, right?
Correct. Correct. You got it right. So
Okay.
if I may just draw what you said, is that we have some polygon and number of sides are unknown,
Mm-hmm.
and we may have some of the interior angles as 150 and some interior angles as 140, and one more information, twice as many of 155 as a 140. So I may be looking at two 155s and one of them as 140 or more, right?
Mm-hmm.
So how many are there is unknown. And we have to find the number of sides of polygon.
Could you walk me through this one?
Sure, I'll do.
Okay.
But there are two approaches to this, one of which is through the interior one, the other would be exterior. We've already practiced few questions which were of 1 mark or max 2 mark each, where interior angle was given and number of sides were asked. Still, number of sides are asked, but interior angles are given again. Now,
Mm-hmm.
this time there are two. I will first go with the concept of interior, then do the same with exterior. If I just consider the same diagram and number of sides is unknown, so I'm not closing it. We have these angles, which is 155 or 140. And what I know is 155 are actually twice than those of 140. So if I say these are x angles, these should be 2x.
Mm-hmm.
So if 155 are twice and these are unknown as x, may I say the sum of interior angles would be 155 times 2x plus 140 times x.
Yes.
So if these are the interior angles, on the other side, may I say interior angles is n minus 2 times 180, sum
Yeah.
of interior angles.
Oh, okay.
And do we agree that n is equals to 2x plus x, that is 3x?
Yes.
Because if these are 2x times and these are x times, sides should be 3.
Mm-hmm.
So just replace this 3x minus 2, 180 on the other side. Please allow me to use calculator. Being teaching to A levels, I have a habit and I've lost the touch of mental math.
It's okay.
So 310x plus 140x. The good part is now that we have only one unknown, that is x. So 310 and 140 is 450 on left hand side. And on the other side, 180 times 3 is 540x minus 360. Now we rearrange. 360 equals 540x minus 450x, that is 90, and x is equals to 360 by 90, that is 4. And now a very, very common mistake what students do is when they get this 4, they write this 4 in the answer space,
Hmm.
forgetting that we've actually found x, and the original question wanted number of sides, and number of sides are 3x. That is 3 into 4, which should equal 12. So number of sides are 12. And let's do the same question with the concept of exterior angle. Exterior is always easier.
Can I copy the equation you have for a second?
Yeah, sure.
Okay, thank you.
Welcome. Okay, if we go through the exterior section, this is what we thought. We had this in our mind that 155s and 140s somewhere. So if we just draw the exterior angles, this would be 40. And on this side, 180 minus 55 is 25. And we have double of these, and we have one of these. So I may say that exterior angle, sum of exterior angle would be this 25 times 2x plus 40 times x.
Mm-hmm.
Take your time.
What do we call the exterior angle, you said?
Yeah,
Yeah.
360. Any confusion in this very statement?
No.
So sum of exterior angles of any polygon is 360.
Yeah.
So we have actually reduced the number of steps. 25 times 2 is 50x plus 40x is equals to 360. That is 90x is equals to 360. And if you may see, we just had it here
Mm-hmm.
after say 3 to 4 steps. And x is now 4 again. So if these are 4 angles, these must be 8 angles. And in total, we have 12 angles. So number of sides is 8 plus 4, 12, or still 3 into 4, 12. You may write it as you wish.
Wait, could you explain the part where like we added 8 plus 4 again?
Yeah, sure. We had some angles which were 40.
Mm-hmm.
We have some angles which were 25. Those which were 40 are one time or half of those which were 25. So we just got the value of x, which is 4. So if that's 4, this should be 8. And total angles are 4 plus 8.
Mm-hmm. 3, 4, and then goes to... Okay. So because there's less 140 than 155, it's just going to be double the amount. So we just add them together and it goes to 12.
Yes. Or
Okay.
we go directly with this initial statement and initial consideration which we made, that was n equals 3x,
Mm-hmm.
and substitute this x right here.
Yeah. Okay.
Okay, now let's have a walk through few names of angles and basic concept, because they always merge angles. with polygons. So consider these lines as parallel.
Mm-hmm.
And then we have these two lines as parallel. Now
Mm-hmm.
we'll be naming these angles as with alphabets A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So I have 16 angles.
Mm-hmm.
So what do we see if I say or I ask what is the relation between angle A and angle B? What would you say? What do you know about them?
That they both
A,
equal to 180?
that's right. The sum.
Yeah, the sum equals
The
180.
sum is 180. And they're known as adjacent angles on straight line.
Mm-hmm.
Adjacent angles on straight line. So name any other example other than A plus B for the same property.
E and F, I and J,
F, that's right. I and J, that's
M,
right. M and N, that's right.
K, L. Yeah, like all the O, P,
There are
G, H.
many.
Yeah.
That's correct. That's correct. And let's move on to the next property. What can we say about A and D?
They're the same.
They're the same. They're equal. And the name given to them is vertically opposite angles. So name a vertically opposite angle to N.
Where's N? Oh, O.
That's so correct. Name any other set which is vertically opposite.
C and D. I mean C and B.
C and B, correct. Okay. So this was one of the name. This is second name. If I say, if I write A and I write E, what can you say about A and E?
They're also equal.
They are also equal. And what name do we give them? That is corresponding angles.
Hmm.
They're named as corresponding angles. If I ask you to name a different corresponding angle for A, what would it be?
M and I.
That would be I only,
Only
not
I.
M. M is corresponding to E.
Mm-hmm.
That is obviously equal to A because A and E are equal and E and M are equal, but A and M are not known as corresponding angles. Corresponding angles are those which are just slided over a straight line. For example, we have this straight line and this, let me say this is line 1, this is line 2. Now I'm sliding line 2, keeping it parallel. So
Mm-hmm.
if I slide it to right, keep sliding it, these are corresponding angles. We may have equal angles with different names. So
Okay.
corresponding one, we slide. If we can just clap our hands and move my hand in a way that the finger stays in line. So the angle between the thumb and the first finger are corresponding angles. Clear?
Yes.
So adjacent angles done, corresponding angles done, vertically opposite angles done. What were alternate angles? Alternate angles were those if we make a Z, these two are alternate. Or if we make Z in this way, these two are alternate. The line has to be parallel for it to be named as alternate. And one of the pair is C is equal to J. Can you see that? C and J.
Mm-hmm.
So these are alternate. Name another pair which is alternate.
You put G and N. I mean, yeah,
G,
G and N.
correct. And if I may ask you to name correspond alternate angle for D.
B?
D, doctor.
Oh, D. K?
It's not K.
Okay.
If I have to write that Z, you see for D, Z should look like this. And K is actually outside that.
So I.
D is inside. Yes, that's I. And same D, another alternate angle. So if it has to be alternate, I should write my Z on other side. So alternate to D would be,
E?
that's right. So adjacent angles vertically opposite corresponding and alternate angles. Before I come back to this, when we have parallel lines, these two angles are known as interior angles between parallel lines, and they are supplementary. They add up to 180. For example, H plus N. When we add these two,
Mm.
they are 180. And what do we name them? We name them interior angles between parallel lines. And then we have a property. If we just look closely, you may see that this boundary in yellow
Mm.
makes a parallelogram.
Yes.
And opposite angle of parallelogram are equal. D is equals to M, J is equals to G. Any question, any confusion?
Mm.
Have you studied bearing or trigonometry?
No, well, kind of, but not like the ones we learned today.
That would definitely be part of your course. And that's a very good question, which results in full marks, mostly
Okay.
bearing and trigonometry. And okay, so I'll be in a better position to decide when I actually have that look what you're actually studying. So whenever it is possible, do share the book with me or the contents. It's better when you share the book for just, for example, with the names. I cannot gauge the difficulty level.
My
For
school books, right?
yeah, the one you're going through. For
Uh,
example, you say quadratics. So I may not be able to gauge the difficulty level of quadratics.
I
One
know
of
our school books are like the Cambridge checkpoints mathematics for grades 9. It's 9, but we're at grade 8.
okay. Just for an example, if we have x square plus 5x plus 6, can you go through the midterm breaking? Just name the two factors and nothing else.
Factors?
Yeah, the two numbers in the middle. What would they be? Should I do the first one?
Sure.
Would it be plus 2x and plus 3x?
Yeah, because when you add them together, it goes to 5x.
And when we multiply these, we get 6x square, right?
Mm-hmm.
I'm writing another equation, which is 2x square plus 5x plus 3 is equals to 0. And again, I wrote these two and I'm asking about the middle two numbers. What would they be?
Or 5x, right?
Yeah,
2x plus 3x still, right?
2x plus 3x. That's right. So when we write x square plus 5x minus 6, negative 6 this time.
Mm-hmm.
So this is x square and negative 6. What would the two numbers be?
2x minus 3x? No.
2x minus 3x. Yourself, you said no. And yes, that's a no.
Yeah.
And why is that incorrect?
because it would be less than like a negative 6x. It's not negative 6x.
We have two conditions.
Yeah.
The sum of these two should be equal to the one in the middle.
Yeah.
Product of these two should equal the product of the ones on the extremes.
Yeah.
So if we add these two,
6
we
times.
don't get 5. When we multiply these two, yes, we do get negative 6, but we have to satisfy both conditions.
Hmm. Negative 2x minus 3x.
Negative 2, negative 3. When we multiply these two, what do we get?
Oh, multiply. Yeah.
We
Okay.
get positive 6. So this is not our answer.
Negative 2x plus 3x.
Okay, 2x plus 3x.
Oh,
When
no,
we multiply, what do
negative
we get?
2x.
Third attempt.
Negative 2x plus 3x, I mean, I said.
Okay, negative 2x plus 3x. When we multiply, what do we get?
Negative 6x.
Negative 6x square. That's correct. But what do we get when we add them?
When we, oh my gosh.
We get plus x. We should get what? We should get 5. Now here's the catch. We know for sure that we have to multiply these two, right?
Yeah.
So negative 6x square is not going anywhere. It
Uh-huh.
is not going anywhere. We just have to think about 5. So what if I take the LCM of 6, which is 2, 3 times and 3, 1 time? I'm actually coming back to the previous first example. Then I'll relate it with this one. This was 6 right there. 2, 3 times, 3, 1 time. Do you need a break? I just saw you flexing. Are you
6.
comfortable?
Wait, what does that mean?
So see, these 2 and 3, these are the factors, right?
Yeah.
And this 6 and 1 could be a possible factor. What that means is 2 into 3 is always 6 and 6 into 1 is always 6. So either these two or these two are my factors. So this is my current question.
Okay.
And I know that to get 6, it is either 1 into 6 or 2 into 3, and there's no third possibility. So whenever I add these two, I do get 5. But when I multiply 2 and 3, I do not get negative 6. So I should have adjusted with 6 and 1. What
Mm.
if I write 6x and negative x? When I add these two, I get 5x. And when I multiply these two, I get negative 6.
Okay.
Quickly, last one. X square negative 5x plus 6 is equals to 0. See, I'm not changing 5x and 1. I'm just changing positive and negative to learn the adjustment of signs. Product should be positive 6x square. So
Mhm.
it is not outside these two. We just have to decide the first one or the second one.
Negative 6x plus 1.
Okay, if we try negative 6x with plus x, when we add these two, we do get minus 5. But what happens when we multiply these two?
Ah, negative 6x squared. Okay.
And we should get positive 6.
Mm-hmm.
That's not our choice. Second attempt.
Negative 6x plus negative, wait, no. Negative x plus negative 6x. Yeah, still no.
Still no.
No, still no.
Mm.
Um,
We'll take a break. Just have a look at this last one.
okay.
It is always 6-1 or 2-3. So before writing, if I see 6 plus 1 is 7, 6 minus 1 is 5, I do get that. But one of them has to be negative. And when one of them is negative, the product would be negative. So I leave the first option and select the second one.
Okay.
So this is negative 2x and negative 3x. What happens when you add them? Do you get this?
Yes.
And when you multiply them, do you get plus 6x square?
Yes.
So both conditions are satisfied. Before we end, like out of discussion, out of nowhere, we jumped onto this topic
Mm-hmm.
and we just came to know that yes, there is some room we can polish this.
Okay.
Very good with polygons. You did better than 90 to 95% of the students. And when I say this, I'm not saying that they will never be able to do this, but yes, they may need 1 to 2 sessions and they'll be very good as well. When we are competing in the outside world, what are we doing? We all get the same exam and we have to score out of 100. One student may achieve full marks practicing like 30 hours. The other may have to practice for 45 hours. But it is true that both of them will be able to achieve this. So what we have to do is collectively we have to filter and decide. For that, we'll need more of your input so we can save our time, tailor our lectures, and cut down those topics which we do not need to practice. For example, we won't be going through tables of 2 to tables of 50. Okay.
Mm-hmm.
So one thing, I need your book to understand the difficulty level. Second thing, for now, we can always change the course. For now, we'll be studying quadratic equations tomorrow.
Okay.
Is it clear?
Yeah.
So starting with the basic concept, increasing the difficulty level, leading up to those where we know that the answer would be in decimals and use of quadratic formula would be involved. Anything you would like to ask or share before we end the class?
No.
Okay.